Okay, so now I'm going to work through some of these prep questions in 10.1, just so that we can double check we're on the right track and we're working through this. Okay, so it's asking for, firstly, number of vertices, also edges, and finally faces. So my first graph comes up like this. I'm just going to quickly draw it. Sorry, my drawing skills leave a lot to be desired. I'm going to quickly label these. So we've got A, B, C, D, and E. It's just worked around clockwise, luckily. So now I can actually see here that I've got an intersection in my graph, but there's no vertex at that point. So what I'm going to do is I'm going to redraw it, because I know that when it comes to the faces that this is going to cause an issue. So I need to keep the same information in there. So I need to keep that connection between A and B, BE, and AC. So all I'm going to do is I'm going to just intuitively redraw it like that. But what I'm actually going to do is I'm going to label this one B and this one A. So I've still got my AB connection there, and then I'm going to have my BE connection here. So I've got my AB here, and then I've got my BE connection here. So that's my BE, and I've got that there. Then I've got my AC connection here. Beautiful, got that one. And then down the bottom, I've got the same E to D and C to D. Beautiful. So now I'm going to go through and work my answers. So number of vertices, again, remember that's these points. So we've got A, B, I've got to stop clicking on the pen. A, B, C, D, E, and it will be the same as over here. So A, B, C, D, E, because again, different graphs but same information. So vertices will be 5. Number of edges. Again, doesn't matter which one I count off, they're the same information in different graphs. So I've got BA1, AC2, CD3, DE4, BE5. Edges is 5. Now my faces. Remember that I'm going to want to use my second graph, because again we've got this intersection here but there is no vertex in there. So I've got my enclosed face, which is 1, and then the space outside of this graph is 2, so number of faces is 2. Alright, I'm going to scroll off that page now and move to my second question. Okay, so again, same thing, it's asking for vertices, edges, and faces. So just redrawing it, 1, 2, 1 in the middle. Make sure that if you are redrawing any of these, that you're just really careful to maintain the integrity of the information, so that you're not adding in any extra edges or vertices, and that the vertices are actually remaining the same if you redraw it. Okay. Yep, so I have copied my information correctly. Now, none of these points are actually labelled in the textbook, but I'm just going to do it so that I've got that integrity of information, A, B, C, D, E, and F. Again, this is just going to help me too with working out all of my edges. So first up, we're going to start with our vertices though. We can see that we've got A, B, C, D, E and F. So 1, 2, 3, 4, 5, 6. So we've got 6 faces. 6 faces. What am I talking about? 6 vertices. Next up, I'm going to go for my edges. So AB, AF, FB, BC, FC, DC, FD, ED, EF, and EA. Okay, so I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that gives us 10 edges. Now, for this particular graph, I don't need to redraw it at all because this intersection in the middle has a vertex there. So my faces will remain the same. I don't need to redraw it. So I've got 1, 2, 3, 4, 5 enclosed faces, and then again my outside gives us 6. So that gives us 6 faces. Now quickly before we move on, I just want to talk about a different concept which we might not have gone over, which is the degree of the vertex. I talked about it a bit in the last video, but I didn't actually explain what it was. So if I want to take the degree of vertex D, so this one here, it's talking about the number of edges that come off it. So you can see here that we've got a degree 3 because we've got the ED, the DF, and the DC. So that it would be a degree 3. If we looked at the degree of F, that would be 1, 2, 3, 4, 5. So it's a degree 5 for that particular vertex. And just remember that on the degree of a vertex, that a loop, good spelling, will be counted twice for the degree. So a loop off of a vertex will be counted twice. Excellent. All right, and we'll leave that there.